Hello and welcome to Level 3 Health and Social Care, Unit 7, Dementia. This week we've got two different sets of PowerPoints for you to look at. And part one is going to introduce you to what is dementia. So, what's it all about, and what are some of the causes of dementia as well? And then we're going to look at prevalence. Okay, the objective that's covered from your assignment by this session, we're going to talk a little bit about the reasons for the increase in dementia in the population, and we'll also address that a little bit more in another set of sessions as well. Okay, but I'm also going to give you a general introduction to what dementia is as well. That's sort of not asked of you from your assignment, but obviously you need to know what it is to be able to write about it successfully. Okay, so what is dementia? It's a term that describes the symptoms that occur when there's a decline in brain function, but it's not just one single disease. We often hear, oh, she's got dementia, but actually there are different types of dementia, and there are different causes and diseases that cause them. One of the most common causes is abnormal buildup of certain proteins in the brain, but they can be different proteins. And this builds up, it actually causes the nerve cells to stop working and then eventually they die. And when nerve cells in your brain die, parts of your brain actually start to shrink. So they stop functioning, but they also get a lot smaller as well. And it's really impossible for them to come back in that sense. So this is a neuron. This is everybody's got them. They're in their brains. Some of you may have done biology before and recognize that little old neuron friend, and some of you may have not. So this is your first introduction. I'm not going to go through it in detail here because that's sort of like a whole biology lesson, really. But what I have done is in extra reading, I've put in a document that I've created called Neuron Notes for you, and that tells you all about the neuron and what it does and what the different bits of it do. So the best thing to do is maybe to stop and have a look at that, have a read through your neuron notes, and there's a little diagram like this for you to complete so you learn what the different bits are, okay, the cell body, the axons, the myelin sheath, those sorts of things. It will be helpful because when I talk about the different types of diseases, I'll mention like the dendrites and that. So it'd be good for you to know what they are really and what they do. It'll just widen your understanding. So maybe take some time out before we go on and read your neuron notes and complete the diagram just to help you later on. You can, or if you would rather, you can go back to it a bit later on. But okay, so assuming that you've done that, let's move on. Okay, so we're looking at the different types of dementia, and here's a pie chart to tell you about the different types of dementia and the percentage of people who suffer from it. And as you can see, Alzheimer's disease, you've probably heard of Alzheimer's disease, is really one of the largest types of dementia, largest causes of dementia. So it's between 60 and 70% of all dementias are diagnosed as Alzheimer's disease. So it's definitely the big one, really. Um, Another type of dementia is vascular dementia, which comes from the effects of stroke, which we have done in our most recent unit. 10 to 20% of dementias are vascular dementia. So 60, 70%, 10 to 20, these are the two big dementias. The rest of them are pretty small, really. Frontotemporal lobe dementia is 10%, Lewy body dementia is 4%, and then there are a few others which take about 1% each. I'll mention those a bit later on. You could do a bit of reading on those, but we'll probably focus a lot on Alzheimer's and vascular and a bit on frontal and temperate and Lewy body. And the others, you could do a bit more reading of your own. Okay. So starting off with Alzheimer's disease, I said it is the most common type of dementia. And it's caused by an abnormal buildup of a couple of proteins. And one of them is amyloid and the other one is tau. Okay. And amyloid leaves little deposits. So if it's an abnormal buildup, so it's like working overtime, you'll be creating little deposits of amyloid around the brain cells. And they're called plaques, and it's a bit like where we talked about in stroke, where the veins get plaque inside them and then they get thick and clunky and the blood doesn't flow as well. Well, this plaque sort of builds up around the brain cells and stops them functioning as well. So they sort of, there you've got a picture of a healthy neuron and they create little blobs. We'll see it a bit more closer elsewhere. So they create little blobs or little plaques which sort of stick and stop the neurons doing their function. And the other deposit is known as tau, which is in they cause little wormy sort of tangles, like little bits of string knotted up, and they form within the brain cells. And both of them clog up and stop the brain cell functioning. So as they get affected, there's a decrease in the chemical messages because these little blockages are in the way, and the chemical messages can't run up and down from the dendrites all the way down. So if the chemical messages can't travel along, so then the messages and the signals and the information doesn't travel along the brain cell as well. The hippocampus is often affected early on in Alzheimer's. The hippocampus is when we looked at the brain, it's right at the base here, and it's responsible for laying down new memories. And that's why memory problems are one of the earlier symptoms that we see with Alzheimer's particularly, okay, because it's affected hippocampus and it makes it shrink. When it makes it shrink, it's not working as well anymore. So memory problems are often one of the first things you spot. So this is sort of a very magnified picture of amyloid B. So you can see it. They look like little lesions in the brain, and it's a peptide. It's a neuron called amyloid B, and we're not really 100% sure exactly what it does. We know it has to be there, and if too much of it is made, it causes a problem. Or when it's not cleared out for the brain, because they're part of carrying the message. It should come and then go when the job's done, and then come and then go when the job's done. So it's either not being cleared out the brain, not clearing off, or not all being used up when the job is done, or too much is being made. A little, still a little bit unsure about that. There's research going on all the time. Because it's part of a role in creating neurons. Again, it's a big issue for the memory for neurons. So for neurons remembering things. So it really interferes with messages, and it interferes with neurons communicating to each other. You remember, or if you've read it, you'll see that the neurons communicate across little synapses, one neuron to another, and the messages get passed down and down and through the body from neuron to neuron. So if this is being interfered with by being clogged up, only half a message, or an incomplete message, or not even a message at all is getting through. Okay, so that's amyloid B. Tau, that's a protein that has another job as well. That if you look at your neuron, it has this very long cable with a sheath around it, and that's known as the axon. And that cable's really important because it's the main transmitter. So the information comes in through the dendrites into the top part of the neuron, the nucleus, and then it's sent down the axon. So whereas one protein was working in one area, this protein is working on the axon. Does the same thing though, really. Its job is to make sure all the information gets passed down, really. So in certain dementias, such as Alzheimer's and frontotemporal dementia, more tau is made than should be. And and that eventually sort of clogs up the cell bodies and the little dendrites, the little fingers that come off the neurons. It starts clogging them up with its little twisty strings. Well, they're actually known as neurofibrillary tangles, but you can call them little string clumps if you want. Okay, and that interferes with the function of the neuron because they're sort of in the way. And eventually, if it really clogs up, they can actually kill the individual neuron. And therefore, no messages will pass because that neuron is going to create a gap between this neuron and that neuron. The one in the middle, if that dies, the gap's too large for messages to get down. So that would be one area of the brain where messages are no longer being passed along. So you've got your two main proteins, tau and amyloid, okay? And both of those can clog up neuron and sometimes even kill it, causing dementia. That's Alzheimer's, okay? So remember, Alzheimer's is caused by the proteins. Vascular dementia, we know a little bit about vascular dementia because it's related to strokes. And it's caused when the reduced blood flow to the brain damages and kills the brain cells. Now we know that happens in strokes, and it could be whatever the cause of a stroke is, narrowing and blockage of the small blood vessels inside the brain, or just one big stroke where the blood supply is cut off for quite a long time. Or remember our TIAs, lots of mini strokes that might only cause some tiny brain damage to the brain, but it could, if you have quite a few mini strokes, you'll be causing little bits of damage here and there, which eventually can cause a wider damage to the brain. Now, not everybody who has a stroke will go on to develop vascular dementia, but some do. Okay, and I think it really depends on how well people recover, how major the stroke was, how big the blockages were, and how long it was there for, really, and various things like that. But that's how it comes around anyway. There's something called mixed dementia, which can come to older people, and people find it quite difficult to diagnose because they find elements of both. So they might find the proteins, or there might be the effect of a stroke as well. And if those two conditions happen to be there together, they will call it mixed dementia. It can be difficult sometimes to know how much, which cause is the worst, if you know what I mean. To be honest, until they do an autopsy on someone, they never really know. And the last thing you want to do is cut someone's head open for that reason. So, people just go along treating all the symptoms of dementia together, really. Not too, sometimes it doesn't matter so much about the cause because, it's the symptoms of dementia you're working with. Dementia with Lewy bodies is a little more unusual, but it does come around. Okay, and they're tiny. They're another little clump of protein, and that protein is called alpha-synuclein, and that develops inside the brain cells. Again, you can see in the graphic here. So they're in the cell area, and you can see where the nucleus of the cell is. All cells have the nucleus. That's the red dot, which should be there. And you get these other little blobs which grow inside the cell. In my graphic, it's a sort of blue blob, and they interfere with the way the cells work and affect the way they communicate, really, by clogging them up. And if this Lewy body blob grows larger, it can kill off the brain cell, and the brain cell dies. It's closely related to Parkinson's disease and often has the same sort of symptoms. So a lot of issues around movement, balance, bodily tremors, risks of falling. So if you see people whose one of the early signs is sort of losing their balance and falling, but then they might also have some of these memory problems, we can start thinking that maybe this is Lewy body, and then they would probably investigate for it as well. Frontotemporal dementia, if you have a look again at the graphic, it really affects a slightly different part. It's very much focused on the frontal lobe and the sides here. Okay, so whatever these different areas work for. So again, if you think back to what you learned in stroke, thinking about the different parts of the brain and the sorts of things they're responsible for, you can get an idea of the sort of symptoms you might be looking at with frontotemporal. Okay, so if you look at my graphic, Alzheimer's disease is to the side and to the back, but frontotemporal has got the motor cortex up here, and then all this sort of personality, some memory at the front. Okay, it often affects people slightly younger. It can affect some of the things you can see first are speech issues like aphasia, because that comes from the frontal lobe. It's often diagnosed between the ages of 45 and 65, or around that age anyway. Whereas Alzheimer's and that, often can be diagnosed 70 plus. It is abnormal clumping of proteins. It's those tau proteins again, the little strings that turn into tangles. But here they're developing in mainly the frontal temporal lobe, so the front and the sides here. Okay. And again, they do exactly the same thing. They clump and they damage the nerve cells. They cause the brain cells to die, and that area starts to shrink. We have some evidence, some research that frontotemporal dementia is more likely to run in families than other types of dementia. So there is a little bit, so if you wanted to find out a bit more about that, you could look it up. Frontotemporal is something you might have heard recently, if any of you sort of follow the movie stars and that. Anybody knows the movie star Bruce Willis, he's just been diagnosed with frontotemporal dementia. He's 67, I believe, but I think he's been having problems with speech, with aphasia speech, and trying to put his thoughts into words and actually coming out with the words, which is not an uncommon sort of early symptom. There are some rarer causes of dementia. Huntington's disease, progressive supranuclear palsy, hydrocephalus. They're quite rare, and really just only 5% of dementia, all these diseases together. So I won't go through all of those, but if you're interested, they're very easy to Google, look up, find out what the causes of Huntington's, corticobasal degeneration. I've just given you a few. They're usually like 1% here, 1% there. So you will not come across them that much. You might come across some people with Huntington's. That very much affects movement in the early stages, the way people walk. They have an unusual gait, as well as personality changes, and some of the memory issues as well. But personality changes are very strong with Huntington's. But I would look that up because, as I said, it's quite rare. You may never meet someone with it nowadays, because it's a genetic issue. And a lot of people have genetic counselling now and may not have children if they carry the Huntington's gene, because it's really not that pleasant. And it affects people a bit younger as well. Okay. But as I said, do look these up. But we really going to focus on Alzheimer's, vascular, maybe some frontal temporal, mainly. Risk factors then. Okay. So what are the risks? Well, it's not an inevitable. Some people think that as you get old, you will get dementia. That isn't correct. It doesn't just affect older people. There are some young onset dementias, and again, you could look into this. They are rare, but it can be about 9% of all the cases, people under the age of 65. As I said, frontotemporal is one, Huntington's is another. Studies have shown that people can reduce the risk of their cognitive decline by being physically active. And this is the same story as we did for stroke and most other things in the world, really. Be physically active, don't smoke, avoid overuse of alcohol, manage your weight, eat a healthy diet, keep your blood pressure down, keep your cholesterol down. It's everything that we said for stroke. Is the same for dementia, really. Keep your brain active as well as your body too. I suppose I would probably add to that, really. Some people say additional risks, depression, socialization, because that's really because the brain's not being stimulated. Low educational attainment, well, same really, cognitive inactivity. Air pollution. Now, there's research, a lot of research going on about this. We finally had one young girl in the UK who the coroner finally gave a cause of death of air pollution. She had a very severe lung condition, and that rarely ever goes on death certificates, so it's quite hard to do the research. But there is, in the time before catalytic converters and, um, the amount of lead in petrol was very high. And there was research to say that, that was affecting people and bringing on the onset of dementia. And lead poisoning certainly doesn't do the brain any good. We do know about that. So if you live in a city, they're doing research really about whether there's higher onset of dementia than if you live out in rural country areas without lots of cars around you. But cars have changed as well, so I'm not quite sure where the research will take us with that one. Okay, so when the brain shrinks, you can see there's a picture here of the brain. On the left side, we've got a normal brain, sort of quite puffed up. You can see the folds. On the right side, you can see that the brain has shrunk. You can see it's like at least sort of, an inch or so smaller. And as the brain shrinks, so the ventricles, which are the folds, they get larger and wider and less going on. And the hippocampus can shrink as well. So frontotemporal dementia, as I said, affects the front and temporal lobe. Lewy body dementia affects part of the frontal lobe here and the motor cortex. So Lewy body, they definitely have some unusual gaits and stances and movements as well. But eventually the hippocampus gets affected and shrinks within all the brains. This too much space and a shrunken hippocampus means it's the hippocampus that actually produces new neurons. So whenever we bash our head, we might kill a couple of neurons. We know that. Or we say we bang out some brain cells. But the hippocampus is what keeps going and puts new ones in where other ones get damaged. However, if the hippocampus is shrunken and it's not doing its job properly, it's not creating new brain cells, and that's it then. The brain will not regenerate. So the brain will degenerate for a period of time. Early days, like maybe, after a head injury or something, it can heal itself. But if you get the shrinkage, and the hippocampus is not doing its job, then those brain cells are not going to be replaced. So yes, we can replace to a point, but if you have dementia, because it's a degenerative progressive disease, your brain's not going to stop shrinking, it's going to keep shrinking. You will not get replacement brain cells. So most dementia disorders, we have to accept are progressive, are degenerative, and are irreversible. However, other causes of injury, as I said, like head injury of a road traffic accident or something like that, a brain tumor where something has grown in the brain, even if it's been cut out, and the rest of the cells are uninjured, there will be a healing process. If the hippocampus is working well, it might replace some brain cells, or you might just have, some memory issues in that area. Or if you have an infection that causes the brain to inflame, as long as it gets treated and goes down, hippocampus is still working fine. Any hormone disorders, that if they can be rebalanced right using the hormone, as long as the hippocampus isn't damaged, they will come back together. Okay, so it can recover to a point, but if that hippocampus gets damaged, no new neurons will be made and you will not be recovering. Okay, so again, if you have a road traffic accident where that part of the brain at the base of the spine, if that gets severely damaged, well, most people tend to die because there's so much else going on there that they often don't survive, because you've got the brain stem there as well, and if that gets affected, you're not able to breathe and such likes. But just remember, hippocampus damage, that creates the new brain cells. Without that, no new brain cells. Okay, prevalence. Little bit of prevalence here for you. Positive trends. Global education is meaning people, are able to keep dementia away to a point. However, people, although health promotion is helping, there are still trends of higher obesity, people eating badly. So although health promotion is helping to one point, unfortunately the behaviours are still going on. So it's still balancing. So at the moment, the trend is still upwards. Okay. So although health education is going to reduce it by about 6.2 millions, so newer people, as people are coming along, their behaviours are still remaining, and that's going up by about 6.8. So and that's particularly smoking and obesity. So they may be doing some things, but people are balancing each other out at the moment, so the trend is still staying the same. And the other thing is an aging population. So as more people are living past 70 and 80, there's going to be a higher number of people with dementia, because because they're there really, and maybe they're not as active as they were, or maybe when you're in your 70s and 80s, you might not be doing all the good lifestyle things that you might have done when you were younger, more sedentary lifestyle. Maybe you're not eating so well, or you're not stimulating your brain. If you've retired from work, your brain might not be stimulated. So it's sort of balancing itself out. All the health promotion is keeping the statistics down. So if you didn't have the health promotion, it would be twice as high. But because people are living longer, you're bound to get more people with dementia. So if you think that the US National Institute on Aging says that people over the age of 65 will make up a huge proportion of the world's population, it's the world is getting older in a way, really, because of all the other medical interventions that are stopping it happening. So you've got a bit of a balance, really. So that means that dementia is increasing. Okay. So in extra reading, I'd like you to have a little bit more of a look at the document covering trends in incidents. So we know it's sort of being kept down a bit by health promotion, but going up because some people are still choosing not to make the lifestyle changes, and going up because people are getting older, and things change anyway, and it's not so easy for them to do the lifestyle changes. So it's staying at the same sort of relevant little progress. But read it up, read a bit more about it, because you will need to answer a little bit about the trends in incidents for the objective that we've identified here. I've also added in extra reading 2 videos to give you a little bit more detail that I think you'll find interesting. So please have a little look at those videos before you move on to the next PowerPoint. Okay, so that's the end of the part 1 session, and I'll see you for part 2. Okay, thanks. Bye.